All right, so this will eventually be the next project. This is a Bristol #0 horizontal mill, and it looks a little funny because to move it, I had to take it apart. Um, so it'll make more sense once it gets back together. I thought I would just give a shot of how it was when I picked it up. That's the base. It's a heavy little guy. Um, Over here we've got the knee. You see it there, and then the spindle. And this is a little bit different mill in that it's a lever feed. You can see here at the pinion here, and then there's a rack. You see right here, this runs here, controlled by that lever right here. Let me back up a little bit. So that's the lever. There's the pinion, and then the rack runs in the bottom of the table. And then you've got the same thing on the head, so it actually moves up and down. So the knee moves up and down, and the head moves up and down. You can see right there where the rack is. I mean the pinion, and then the rack runs down the middle right here. I'll show you what that is. So that sits right in here. The pulley, that's an interesting little detail. I have no idea what that's for. Hopefully we'll find that out as we get into it. You can see it is hollow in there. All right, so normal stuff, get it cleaned up, take inventory of what's missing and what's broken. So here's some pictures when I picked it up. This will give you a little bit better idea of how everything fits together. It looks pretty rough in these pictures, but it's really not that bad. A lot of that is sawdust, grease, a little bit of surface rust like on the arbor there, but really in pretty good shape. Fortunately, the previous owner was very helpful in helping me take it apart so I could get it in the van. I did find a ad. This is from 1914, and it showed two of the machines that they built, and you can see on the left there, that's what it looked like. So that's what we want to make it look like again. All right, so here's a look at the spindle. You can see the pinion there. It goes on the mill on this side, and then that pinion rotates around. I've got it to where I can lay it down flat now without it getting in the way, and that moves it up and down on the mill. So it has traveled just itself with that pinion there on the rack. I thought I'd start taking this apart and start making some notes on it. The taper here is a Brown & Sharp number 9. You got one screw here and then one missing. I'm hoping it's just missing and that's not busted out. These definitely don't look original. Another mysterious hole here. Again, gee, I hope that's original, and if it's not, I hope it's still threaded and not just a hole. It looks like a ring back here. Another one here that's definitely threaded on this end of the spindle. I'm not sure what the threads are on here. You got a keyway for the pulley. Up on the top is where the overarm goes. And we'll probably start by taking these off, take this out, and really just sort of get it out of the way, and then start with trying to take the spindle apart. I'm very curious to see if these are plain bearings or Timken bearings or what kind of bearings are in there. So those all came off very easily. I got the first couple off and then took that off and then backed the rest off, and then at the end I guess this nut is maybe fused to that, and then by just turning the nut out it came out of the casting there. I noted that this is a little bit bent, maybe probably bent around in there, so I might replace it, or might try to bend it out just a little bit. So the next part is this, try to get the spindle out, and it looks like I'm going to need a tool here, and I don't have anything like that, so I'll probably have to take some time here to make one. I could probably just hit it with a punch there, with a hammer with a punch on it, and get it to turn off, but I'd rather just have a tool for it so I can do it right. I tend to break these things and bend them and do all kinds of bad things when a hammer is involved. So we'll take some time and get that made. Alright, so due to the magic of editing, you didn't have to see any of that. So this is an old lawnmower blade. I cut a hook in that, got it to sit in there. I had one of these, same tool, and it is in this outer ring. And then I put it to where it was held by the table. Put this one in here. Put that in my pipe / breaker bar. And yeah, I mean it real easy. So it'll be interesting to see what the next step is. Okay, I have to play with that a little bit. Maybe I can tap this for it to come off. Okay, yeah, definitely need to get a GoPro so I can do this with two hands. That other one was on the bottom here, holding this in place. It threads on too. So, one of the reasons you check, rather than just smacking it with a hammer to see what happens. Alright, let's see what's in there. Alright, so we took the other one out and really just lightly push that. Comes out this side. You see, it's interesting that it's sort of tapered right here. I guess that would mean, I don't know. You see it tapered on the inside here. I wonder if this is like just a dust cover for the bearings. What the other side is like. If I pull it back this way, then this comes off. Okay, so we've got a spacer here. Oh wow, okay, that's neat. I'm gonna go ahead and guess that hole is some oil to go in. So it probably was not supposed to be greased. And I guess those would be plain bearings. So that's gonna push this very early in its time frame. Okay, neat. So push this over here. Seems to be the same thing. Go ahead and take everything out. Very nice. Okay, cool. Let's see what the rest of it looks like. Okay, so looking down into the spindle, looks like there's a little bit of wear in there. Then you see the hole there, and that's going over to this it's basically a grease fitting. And I'm wondering if that was supposed to be a Zitz cup, and this is supposed to be oil. So I'll have to check. Yeah, it's pretty rough in there. So it's definitely plain bearings. It doesn't look too bad. Alright, so this is a pretty cool detail. You can see that little knob right there on the inside. Let's see if you can see that. See how that's raised up? You can see where it comes in from this side, maybe from this angle. So that's going to sit in this keyway. So one keyway down here is for the pulley, but right here is going to hold this, well, this way, this bearing right there. So it stays on the shaft, and then it turns in here. There's a bearing in the casting. So I guess as these things wear, and I'm gonna go ahead and guess again that that's probably how much they've worn. Probably started here and now it's in like that. And probably the same thing on the other side. You just tighten the nut there, and you've got the spacer, and that's able to account for the wear. So that's pretty neat. And I guess when they wore down, you'd buy some new ones. But now we're 100 years later, and they're out of business, so we're not going to get any new ones. But it'll probably be just fine for our use. Alright, I've got the flash of the light on here to show you what I think is pretty cool. So if you look down in there, I'm not sure if you can see it, but that area in the middle, so you've got the bearing here, the bearing surface here, and then the bearing surface here. You can probably see it from here. That, I believe that's felt on the inside. And then I think that this goes straight, this one goes straight down into the felt. These two fittings are for each end, and then this missing screw and the one, back out, the one screw here okay, sorry about that. So there was a missing screw here, and I've took this one out. I think these two screws, or bolts really, hold in the bearing. I think this bearing comes out, and I think this one in here comes out, and then there is felt in between the two, and I think that's what's supposed to hold and keep the oil in there. That sort of forms the oil reservoir. I think that right there is the access to that. These are where those grease fittings were. I think that's just wrong. So you get the Gitz cups to go back on that. And I think I'm going to go ahead and try to take these out so I can get everything cleaned out so that the oil will be able to flow in there easier. Alright, so I was sort of right. There is a bearing in there. It does come out. It is held in place here and here, but it's not two bearings. It's one long bearing. To get it out, it's pretty easy. You turn the spindle around, put it in the other way. See, it usually would have been in this way. You put it in this way, and now you can just use your press to press it right out. And the reason that was obvious was because how would they have gotten this guy in here if there wasn't something in the middle? So now we know. And I can take this out, soak it. It's got the felt in it. How they got that in there, no idea. You can see clearly the hole here that would fill up the reservoir where the felt is, and then the holes on each side where these bearings meet on this side. So get everything cleaned out of here. I've got this apart now. Take these bolts out, and I'll be able to paint it. So that is the spindle. Pretty simple. Nice little ingenious design too. Alright, so next up is the knee. See this part right here goes down on the base, and then as you turn this handle here, you look inside, you see the two crowns on this, and there's an acme threaded rod here. So you turn this, it turns that, and basically this is pushed down into the base, so it stays still in the base, and as you turn this rod, it pushes this up or brings it back down. And then you can see here's the pinion. Let me go ahead and show you the table sits on this right here, on these dovetails. So the table sits here, and it slides back and forth, and that is done with a lever action. Turns this pinion here, and then there's a rack underneath the table, and so that's turned right here. You can see that moving, and then this, I guess you would describe as the Y direction. So this would be the X, this would be Y, and that would be Z. And so let me see if I can turn this around just a little bit and come over here. So as you turn that, this is a more typical approach. We're using a screw. There's an acme threaded rod here with a nut right in here, and as it moves back and forth, it's going to push the table this way. So I think probably just take this off to begin with, remove some of these things. I've put a little bit of penetrating oil in here. It looks like it's stuck in there pretty good, and start taking these apart. And I think if I can take this top off first, that would be a good step. I tried to move it a little bit by turning the Y here, and it doesn't really move. So I guess I got the penetrating oil down in there. We'll loosen up the gib and try to get that to move first, and then take the top off. I think once I take the top off, this piece will be in it, and it probably makes sense to take that out. This will remain in the knee, so probably either take this one or that one out, and that should let me get this rod out, and that should take it all apart, then prep it, paint it. Hopefully nothing needs to be fixed, and it'll just go back together. A couple more details. I got the penetrating oil did its work. You can see this when you turn it up this way. You can see that gib move down, and that firmly holds the table in place. There's let's see if we can see it. 1, 2, 3 holes here. I think this big one down here at the bottom, not much light, is the same here as this one on the top. I think I'm missing this, and I think these two probably had just bolts that went in them. It also looks like it's a similar, you can see a hole in that, a similar deal here that you would turn. So either going to be fabricating these or hoping to find some that are similar. And so that's 2 things at least that will need to be replaced. But with that loosened up and the penetrating oil in, I was able to move the table up and down pretty easily. So that's good. I think to take it apart, it looks like maybe if I take this one bolt out here, that's going to take the nut that holds the nut. So I should then be able to just slide the table up and back out a little bit so you can see the whole thing. You get the nut, it's going to be in this. You take that off, and I think the table will then slide up and off. Yeah, so that worked nicely. As you can see here, that was connected there, it's bolted in. And I think the suspicions about these two are right. You can see that these holes don't go through the gib. You don't see them coming out here. Where this one comes down, you can see that it's going to turn freely in there and then hold the gib up and down. So I think we can take this one out. Yeah, so I'll be needing one of those. Probably shouldn't be too bad to fabricate if I can't find one. And the gib comes out like that. I think now we know why one of them is missing. It looks like I have to. Hopefully, we can just drill a small hole in there and it'll come out with an easy out. This one looks suspiciously about the same way. All right, now that that's out, I think the next logical step is to go ahead and take this out, this one out, and then take this out over here. Maybe I'll do this one first. Okay, so the next step is I'm going to take this out. Fortunately, I've got one of these that fits it pretty good. I'd hate to have to make another one. I've already made the bigger one for this one, and you got this little set screw in here. So take that one out, check, make sure there's not another one under it, and then I think I should be able to take this out pretty easily. And I guess this could press out. If that has a keyway in it, or maybe this has to go through. So this end here was not threaded. It does have this. I think maybe that was just to help you, I don't know, maybe break it loose or adjust it when it's in. Maybe get the adjustment once it's in. But it just presses into here presses out. You get a key on here, and gear fits on here. You can see the keyway there. I take this out. A little bit of a, yeah, and then that itself moves. So it looks like that slides on that. And then this whole thing right here, I'm pretty sure lines up with that hole. And that is what you use when you tighten. Tighten that down in there. Keeps that, let's see, it comes down in like that, keeps that from turning. I think it's how you lock the table in place. So it looks like there's not anything else in there. So that concludes taking this part that sits just under the table out. So we'll clean that up and get that bolt out. So far, so good. All right, so here's the lead screw for the side. Right on that, and see, this is it looks like it's pinned. You can sort of see that right there. Yeah, so it's pinned through there. One really nice thing is you can tell, like my Hindi lathe. The Acme threads here in the middle, where it was used a lot, were so sharp. They were like razor blades, and so that gives you a lot of backlash. So there's a lot of slop in that. So these look really nice in that area, and I looked in the nut, and those look great too. So it looks like this isn't worn out. So that's really good. A little lubrication hole there. This went in on top of it, and it just threads in. I think we're gonna probably find a similar thing here, so we'll do that next. Interesting detail here. I went to take this nut off, and as I turned it, the whole thing just turned freely. And then I also noticed right here, that's interesting. I haven't been doing things like this that long, but that's the first time I've seen something like that. So that's kind of neat. It's got like a little set screw in the nut. So we'll take that out and see if we might have to hold this still and then thread it out. All right, so this came out pretty easy. There was, I couldn't really figure out how this came apart, but from the back you could see this bolt just sticking up on top of the crown. So you took that out. See, it was threaded into the rod here. This sits below that. And this is interesting. Well, ball bearings, how about that? There's one place on here it's not plain bearings. So little captive ball bearings in there. And that came out, and then once that was out, it was really the only thing holding that up. I hope you can see it, brightness adjusts here. And so we're just going to push that down, and it'll come out the other side. And if you look down in there, that's the first evidence I've seen of chips. So somebody was milling with this. It's actually the first place I've seen it. The whole thing has been just sort of rust and grime. So there's some chips down there. Well, believe it or not, this is a table. So it has spent the last, I think probably 3 days in the electrolysis rust removal unit. And it's come out really good. It didn't happen to fix where the table got knocked off, but we'll fix that in just a little bit. It shouldn't be too bad. Fix that on the Hindi. Really an amazing shape. It's got a couple marks. You got one here, a couple little places where it was hammered on, one little dig in right there, and a few hammer marks. Really in great shape though. And the bottom looks good as well. You can see the, I think this is the rack for stop locks, because that's very handy with the lever action, and also you could use it as a clamp. All right, so I'm going to flip this over and we'll look at the where the rack is. All right, so that's the rack. You see it running right along here. So instead of having a long lead screw and then handles on each end to move it, it's fed with a lever that has the pinion on it that's on that rack, and it just feeds it through. So it was really good for production thing, for sliding, gear cutting tasks. It would just be the same over and over and over. It doesn't, of course, have the same precision that you might with micrometer handles, screw handles on each end. But I might retrofit that at some point. I saw another one on the Practical Machinist forum where someone had retrofitted it, or at least they got one that was retrofitted, and that looked pretty neat. But for the time being, I'm just going to leave it as it is. So I got to fix the corner on this, and then we can clean it up, and it will be ready for paint. All right, so a couple ideas on fixing the damage here to the table. I've got an old 1898 Hindi lathe, a 14-inch swing on that. It had really the same thing, and the corner was broke off the tool tray that goes on top of the quick change box. The difference is it was pretty small, just a little bit area here and not near as thick, where this is a big area here, and look how thick that is. The way I fixed it before was I drilled a bunch of holes in here, and I ran copper wire down into the holes and sunk them in JB weld. Basically made a mesh all the way around, and then JB weld has a like a putty, a steel putty, and then I formed that all the way around, and it turned out really good. It's very strong, sticks easily to this, easy to shape, and that worked great. But it's pretty expensive, and being this thick and that much, I don't know, it might be sort of the wrong way to do it. I was also thinking that I could go to the other side of the table, which is the same, which is a little bit different on the Hindi, and make a clay mold on this side. Go ahead and do my mesh and put the clay mold under here, and then use a fiberglass putty. They've got, it's not like Bondo. They've got some that has a fiberglass strands in it. Fiber strand, I think is what it's called, and that's very strong, and that would work well. It's not structural. It's just for looks. I'd like to have it on there because it does look a little bit better. I'm going to go ahead and get the mesh in. I'm going to need the mesh one way or the other. And then I'll take a look, and I'll be able to see a little bit more exactly how much needs to be filled in. So I'll get that in. I went ahead and with the little grinding wheel, cut this off flat so that I could get one hole in right here, and then I can get another hole in here. So I can get that one piece all the way around this way with the exact profile, and then sort of stitch it in across here, and that'll give it some strength. All right, so I got the sort of the skeleton in place. This is a heavy gauge copper wire. Like I said, I cut this area off and then drilled a hole pretty deep. I mean, it goes into about right there. I did the same thing over here, and then these are epoxied in with JB weld. And then along the bottom, you can see I've also drilled holes in here, 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 and here, and then put those in with JB weld. They also go pretty deep, and then soldered them to the wire on the top. And so what you end up with is a very, very, very strong support in there. I mean, this table's very heavy, and I can move the table with that. And now I'll go back in and put this steel stick in. I mentioned before that I thought maybe I wouldn't do that because it was so expensive. This is what I'm talking about. It's a putty. If you look in, well, you can't quite see it. It's two parts wrapped around it. So you cut off a piece and you mix it together. It makes a mess. It's real sticky. Doesn't make a mess. And it's an irritant, so you have to use gloves. And then you put it in there, and it's sort of like clay, and it sets pretty darn fast. And then it has very metal-like, like cast iron-like properties. It files very well, and it's hard to describe. It's not like Bondo or fiberglass stuff is you sanded it or file on it. It goes away really quickly. This doesn't, and so it's easy to shape. It's got a lot of structure to it. I mean, it's not structural, but it has a lot of structure to it. I mentioned that I was thinking about not using these because they were so expensive. The last time I bought them, they were, but I paid less than $6 for them this time. So I got 3 of those. I've got a little bit of one left from the last time I did this, and I'll be putting that on there and shaping it. And then that should go pretty quick. I'll take a couple shots of video as I do it, kind of show you how it works. So that should fix the problem. I mean, again, if it were structural, I would want to braze something on there or try to do some welding on the cast iron. That's not really my strength. I'm not really, I'm not into welding cast iron. So it's, you know, I'm kind of getting away with it since it's not structural. I'm just going to put that on there. So it should be good. So here's the first little bit done. Get a good look at it, and you see it sort of kind of looks a little bit like cast iron. It's got this kind of the same color as the casting. So it stays in place. I've just put this on, and I can still squeeze it a little bit, but it's not like another other epoxy that would run. That's sort of gives it an advantage. It's more like clay. I'll give you a look from this side. It's a little bit proud of the lines that I want because I'm going to be able to file that down. So I've got this little last bit to go. It appears I bought way too much. I've only used about maybe 3/4 of a stick so far. So I'm going to have a good bit left over. But that's good. I'm sure I'll find other projects that need it. And nothing else got done. So I think I found out why those 3 tubes of the steel stick were so cheap. They were too old. They didn't work. They crumpled. Instead of it being like clay that you know, massage with your fingers and mix it together and it makes it a epoxy, it just crumbled like a stale biscuit. So it's somewhat ironic that the 3/4 of a tube that's been in my shop here for at least 2 years was newer than what was in the store. So go figure. So in the meantime, I got this out. Used to have a lot of trouble with these. I found that having a drill press makes all the difference in the world. And a center drill and nice clamps and all that. To be able to get a hole exactly in the center of this and get it to a controlled depth makes a big difference. And then that way when you put the extractor in there, it goes straight in, and this is probably loose too. It probably wasn't snapped because someone was unscrewing it and they probably screwed it in too far. So it's probably the only reason it was broken, because it came out real easy. So we'll try to find some steel stick tomorrow and finish that up. I'm going to clean up the rest of these parts. Got a couple little things to fix, but that's going to be an early night. It's kind of disappointing. I was really looking forward to getting the rest of that done tonight. Oh well. So I've got all of the steel stick on. On the outside, I tried to be pretty proud of it, so that, you know, because it's easy to file and shape, it's easy to remove. On the inside, I tried to get much closer to the line I want, because it's obviously a little bit harder to get in there and get that worked. So I give this about an hour. It says it cures fully in an hour. It'll go through and file that off. You see I've already just sort of run a file over these parts right here to make sure that I didn't have any really low spots and fill them in. So I might have a low spot or two, and that's not a big deal. You can just put some more on. So I'll shoot another little video after I've filed it a little bit. And that'll be about it. It's really, really a nice product. I mean, I didn't put this on. it hasn't even been 5 minutes and it's already pretty set up. One thing I do that works really well is put really small, I'm only doing cutting off about that much, probably about a ½ inch off at a time and mixing that up. And I'll alternate sides. So I'll put it on this side and then put it on this side. And I do it thinner than what I want here, just a basic shape. And so by alternating sides, when you come back to do the other side, it's already set up a little bit. And so that helps give you a guide. So you're not, when you're pushing it in here, you're not messing up what you just did. And then alternate back and forth and fill in. And then you go back each side and make it wider. And so it's proud of the surface that you're going to shape down to. So that's about it. It's pretty easy stuff. Works really good. It also says on the package that you can mill it and tap it. That sounds a little extreme, but that kind of gives you an idea of how strong the material is. The number one ingredient on it is iron, so it's nice stuff. All right, all the final shaping is done. It turned out really good. I'd love to say that you'll never be able to see it, but the last time you could clearly see it because it was the smooth area. You can see the casting is kind of rough and got the dents in it, and you come over here and this can be nice and smooth. So I think I'm going to try to distress this a little bit such that it sort of matches the rest of the casting before I paint it. So we'll see how that works. It's funny to make something nice and smooth and perfect and then go back and distress it, but I think that'll look better than I mean, not that the other one looked bad, but it should make it more indistinguishable. One of the things I noticed as I was cleaning all the parts, you see casting numbers every once in a while, but usually they're cast in, not stamped. And I thought this was interesting because I saw this in one place at 429, didn't think much about it. And then as I was cleaning the side of the knee, it kind of looked to me in the dirt and grime that someone had written 429 with like one of those yellow grease pencils. And I checked, and sure enough it was. And then I started noticing as I cleaned everything else, 429 stamped and everything, including the Gibbs. So I guess this is mill 429. And I guess they did that to fit all the parts together so that they fit the same. So that's pretty cool. This guy was precision enough that they bothered to keep the parts together and fit them all the same. It's kind of neat. So it is time for paint. Have everything cleaned, everything masked off, and ready to start painting. So this will wrap up part one here. I'll paint these, and then the next time in part two we will start putting things together. See you soon.